Okay, today we're looking at graphing quadratic inequalities. So if our problem asks us to graph y is less than x squared plus 3x minus 4, we want to go about graphing this. So the first thing we're going to do is we need to decide if our line is going to be solid or dashed. So we need, we're going to use our inequality symbol to determine that. So it's going to be solid if it's got the equal to. So if it's greater than equal to or less than equal to, or it's going to be dashed if it's just the less than or a greater than symbol. So in our case, this is going to be a dashed line. The next thing we want to do is we want to graph it. So you can either plug in some points to graph it. You can find the vertex and then plot your points from there. Or you can use your graphing calculator and go to the table in order to plot some points. So if we were to do any of those things and plot some points on this problem, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. We'd have the point 0, negative 4. We'd have the point negative 1, negative 6. We have the point negative 2, negative 6, negative 3, negative 4, and negative 4, 0. So those would be our points. We'd also have the point 1, 0. And because this is just a less than, we would dash our parabola. So our parabola would be a dashed line. We know that the vertex is somewhere down here in between negative 1 and negative 2, so we're just going to kind of guesstimate and draw it in from there. The next thing we need to do is decide our shading. So step 3 is to use a test point to shade. Okay, so if we use the point 0, 0, 0, 0 is not on my graph, so if we plug 0, 0 into our equation, so our inequality, we're going to have 0 less than 0 squared plus 3 times 0 minus 4, which would give us 0 is less than 0 squared plus 3 times 0 is just 0, minus 4 would be negative 4. We want to look and see, is 0 less than negative 4? Well, 0 is not less than negative 4, so that means in here where 0, 0 would be, which is inside my parabola, would be a no, so we don't want to shade in there. We're going to shade on the outside of our parabola. So we're going to shade everywhere outside my parabola. Because inside my parabola I had a test point that was a no, we're going to shade the outside. The next thing we're going to look at is if we have a system of inequalities. So on this one, if I have y is less than or equal to negative x squared plus 4. And then if we have the inequality y is greater than x squared minus 2x minus 3. We're going to start the same way by deciding solid or dashed. We know our first one is going to be solid because it has the equal to, and the second one is going to be dashed because it is just a greater than. So now we need to go in and plot some points. Okay, so if I start with my blue graph, it says a y-intercept at positive 4. And it is reflected, so it's going to be going down. So we can plot our points. Again, you may use a calculator in order to find these points. So we know it's facing down. There's my first inequality. It's solid because it has the equal to. So if we test 0, 0 for my blue inequality, we'll have 0 is less than or equal to negative 0 squared plus 4, which would be 0 is less than or equal to 4. This is a true statement. So that means we're going to be shading inside this blue parabola. Now we're going to go through and do the same thing for my red parabola. So we need to graph the inequality y is greater than x squared minus 2x minus 3. Again, you can type this into the y equals of your calculator and go from there. So if we plot our points, we've got one down here at negative 3, then the point negative 1, 4, the point 2, negative 3, 3, 0, and we also have negative 1. This is going to be a dashed line. And if we test this point, we have 0, 0. So we'd have 0 greater than 0 squared minus 2 times 0 minus 3, which would give us 0 is greater than negative 3. Once again, this is true. So that means we would shade inside my red parabola. So the solution to the system is where those things overlap. So we want to shade in where they overlap. So in this situation would be right here in between all of them. So we're going to shade, darken in the parts in between. And that is the solution to my system of quadratic inequalities, is right there where they overlap.